this lesson, we're gonna learn about what a logarithm is, and I'm gonna do a couple of these with you, and then I want you to pause the video and see if you can do the rest of them as you go along. It's really not. I think the part actually number 2 you probably could do before you could do number 1, but I just want to make sure you understand the notation here. So what they're saying is, for part A, what power of 2 is 8? What power of 2 is 8? Yeah, think about that. What power of 2 is 8? And the answer is 3. Okay? What power of 3 is 9? And the answer is 2. And the reason why is because 3 to the second power is 9. See that? So what power? It's the second power. 3 to the second power is 9. Okay? Here, 2 to the third power is 8. So that's why what power of 2 is 8? It's 3. What power of 3 is 9? It's 2. All right? So that's kind of what we're doing at here. So see if you can do some more of these. Maybe if you want to keep watching, I'm going to keep doing them. And when you think you could do them, I want you to pause the video and see how you do. What power of 6 is 36? That's how you read this expression. What power of 6 is 36? So we have 6, and we want to turn it into 36. What power? What do you have to do? What would the power be? Well, it would be 2. Okay, because 6 squared is 36. So that's a 2. What power of 2 is 32? What power of 2 is 32? 2 to the what is 32? 2 to the 5th power is 32. Oh, I'm erasing that. What power of 10 is 1,000? Okay, what power of 10 is 1,000? 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. And that's what they want here. So that's going to be 3. 10 to the third is 1,000. And I want you to really, I want to say, why are we doing this? You'll see why. Okay. What power of 12 is 12? What power of 12 is 12? So I have 12 and I want to keep it at 12. 12 raised to the first. 12 to the first is 12. What power of 3 is 1/3? What power of 3 is 1/3? 3 to the what gives me 1/3. Think about that. How do you get a fraction 1 over? It's a negative exponent. So 3 to the negative 1 is 1/3. 3 to the negative 1 is 1/3, so that would be negative 1. What power of 5 is radical 5? 5 to the what? 5 to the what is radical 5? Now think about what the radical is. Remember the radical, power over root. It's a square root, so that would be 1/2. It's a fractional exponent, gives you the radical. What power of 42 is 1? So I have 42, and I want to turn it into a 1. How do I make 42 be a 1? How do you raise something and get 1 for an answer? Hopefully you remember, it is 0. Okay, so 42 to the 0 power is 1. Anything to the 0 power is 1. So if they say, what power of anything is 1, your answer is always going to be 0. All right, so you just got to do some thinking here. So now fill in each of the blanks. 4 to the what is 16? Squared, right? See if you can do these without, without looking, then come back and get the answers. 2 to the what is 16? 2 to the 4th is 16. 10 to the what is 10,000? 10 to the 4th is 10,000. 7 to the what is 1? Anything to the 0 power gives you 1. 6 to the blank is 6. 6 to the first is 6. 3 to the what is 1/3. We did that up there. Negative 1. 5 to the what is 1 over 25. Negative. That's when you have negatives, right? Negative 2. Negative 2. 1/4 to the what is 1 over 64. So we're not flipping it. It's staying 1/4. We just want to make it go to the 64. 4 to the third. 4 to the third, because it'd be 1 to the third would be 1, and 4 to the third is 64. So there you go. And then 1/2 to the what is 8. It's flipping. 1/2 is becoming 8 over 1. So the 1's flipping down to the bottom, so I know it's going to be negative something. And then 2 to the what is 8. 2 to the third is 8. So 2 to the negative 3. I mean 1/2 to the negative 3 would give me 8. Okay, so there's There's our what power. Why did we do all this? It's all for logarithms, okay? A logarithm is a function that finds a missing exponent, and that's what we just did in those two exercises. We said, what power do we need to get a bigger number or a smaller number? Because sometimes it goes fractions or whatever. It could be a smaller number, but either way, you're changing the base to a different base. You need an exponent to do that. All right, so a logarithm is an unknown exponent. Instead of writing what power, because that's kind of annoying, what power, what power, what power, we can simply write log, log, and that stands for logarithm because, again, a logarithm is an exponent. I'm going to ask you in class tomorrow, what's a logarithm? And I want everyone in unison to say an exponent. Okay, we'll see if that happens. The statement 3 squared equals 9 is an exponential equation. There is another way to express this kind of idea. We've kind of been doing that. If I write 3 squared equals 9, it has three parts. 3 is the base, 2 is the exponent, and 9 is like the amount you get. So 3 squared is 9. Does that kind of make sense? We all know that 3 squared is 9. 3 is considered the base, 2 is the exponent, I think you know that, and 9 is the amount you get. This expression can also be written like this. This is called logarithmic form, log form. And it's the same thing as what power, as the what power function, except instead of what power we write log. Log base 3 of 9 equals 2. So the way you read that is the log base 3 of 9 is 2. In other words, the exponent of 3 that makes 9 is 2. I'm going to let that sink in for a second. The exponent of 3 that makes 9 is 2. The log always equals the exponent. That's very important. This is a log expression, and it's going to equal the exponent. Unknown exponent. Why? Because a logarithm is an unknown exponent. A log statement isolates the exponent. 5 to the third equals 125 can be written log base 5 of 125 equals 3. 9 to the 5 halves equals 243 can be written log base 9 of 243 equals 5 halves. It's all the same thing. This is 5 to the third equals 125. A logarithm is an exponent. Okay? It's an unknown exponent. So if you're finding the exponent, you're going to be using logarithms. And we're going to get into a ton of practice on this now. Okay, so we have some exercises here to roll through. So here's the conversion. B to the n equals a, log base b of a equals n. And that's exactly what we just said here. That's this right here. I'm going to erase this. That's going from, this is exponential form, and this is log form. We want to turn log form into exponential form if we want to solve. All right, so here it is. This is exponential form right here, and this is log form right here. Exact same thing. Rewrite each exponent, each using exponent notation. So exponent notation. Where's my base? 5 is the base. Where's my exponent located? Right here. 2 equals 25. And that's all you have to do on these exercises here. 5 squared equals 25. Is that true? Yes. If it's not true, you did something wrong, obviously. The base is 3. Exponent's -2. 3 raised to the -2 equals 1/9. Equals the amount. There's the amount. See, this whole lesson is just getting you to understand where's the base, where's the exponent, where's the amount go. Okay? Very, very important to know how to go between log and exponential form. That's what this whole lesson's about. So same thing over and over again. X to the 2.61 equals 29. And we could solve that if you wanted to, but that's not what it's asking us to do. It's just saying rewrite in exponent notation. X to the 2.61 power equals 29. Now go backwards. Rewrite each using logs. Okay, well here's my base. 6 is my base. Log base 6. It's a little subscript. and the amount is 216, equals 3, the exponent. This one, I'm going to do it over here. Radical 49, you have to know that that's 49 to the 1/2. And if you're going to write it in a log form, we should already know that. We've been doing that for a week now, right? 49 to the 1/2. Okay, so where's my base? My base is 49. My amount I want to get is 7. And my exponent is 1/2. It takes an exponent of 1/2 if I have 49. It takes the exponent to be 1/2 if I want to get an amount equaling 7. Log base x of 600 equals 3.4. You really have to think about what you're doing here, guys, as usual. Identify the value of each log. So now we're actually going to do it. 4 is my base. I don't know the exponent. That's what they're asking us to find. I don't know the logarithm. Again, what's a logarithm? A logarithm is an exponent. So I'm evaluating a logarithm here. So the answer is going to be the exponent. So this is asking what power of 4 equals 16? That's what's going on right here. 4 to the what is 16, and obviously we know that that is 2. So the evaluation would be 2. This is 2 to the blank equals 8. 2 to the blank equals 8. 2, what power of 2 gives me 8? 3. 3 is the power of 2 that gives me 8. What power of 5? Remember the warm-up or the opening exercise? What power of 5 gives me 625? 5 to the what is 625? Well, 5 to the third is 125. 5 to the fourth is 625. Log 6 of 1. 6 to the blank gives me 1. We know that that's 0. Anything to the 0 power is 1. So 0 is my missing exponent. 5 to the what is 1 over 25. Well, I know I got to get it to be 1 over, so I know my exponent is going to be negative. And 5 to 25 is giving me 5 squared, so it's 2, right? So negative 2 would be my exponent there. This is k to the blank equals k to the 7th. Just look at that. K to the blank equals k to the 7th. Well, that must be 7. Okay, so now logs on the calculator. We can do logarithms on the calculator, especially when they're like more complicated. Those we could do in our head. All those we just did. But when you see there's a log button on your calculator, we get to class tomorrow, you're going to take a look at your calculator, look for the LOG button. The logarithm on the calculator, the log button on the calculator only does certain log bases. It only does log base 10. Log base 10. So the button doesn't say log base 10. The button just says LOG. It just says LOG, but it means log base 10. You just have to know that. Then you'll notice below it there's an LN button. An LN button. That's the natural log button. We're going to talk more about natural logs, but a natural log button is a log base E, and of course we don't know what E is either. E is a number. It's an irrational number, kind of like pi, which we'll introduce in our next lesson, so we're not going to worry about E right now, but we're going to talk more about LN natural logs and the E value in our next lesson. But for now, I just want you to realize what this is. So log 100. All right, so we need our calculator. Be right back. I'm back. All right, so log 100. We're just going to type that in, and it's 2. I know you can't see that. Log 100 gives you 2 in the calculator, which means what? Well, that means that 10 raised to the second is 100. Log, because the base is really 10. See here, see how it's LOG? That means base 10. So log, I'm going to type in now log 1524. And it's going to be some crazy decimal, okay? 3.18298, blah, 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 okay? Because 10 to the blank equals 1524. Well, powers of 10 are all nice, like 10, 100,000, 10,000. So if you don't get one of those, if you're not trying to get one of those, you're going to have a decimal exponent to get you there. And that is it. We'll just call this 3.19, just to be short. Okay. So 10 raised to the 3.19 is approximately 1524. And then this one here, log of 2 over 15, same idea, right? Log 2 over 15 is negative, because you knew it was going to be negative because it came out to be a fraction. The base is 10 here. It comes out to be negative. We'll just call it 0.875. There's some other decimals in there too. So that means what? That means 10 to the negative 0.875 is approximately 2/15. Approximately, because I rounded it. All right, so that's the idea for these logarithms. And we have another exercise here, another couple exercises. And these two, the change of base formula, we're going to do this change of base. I was going to do it in class, but we're going to do it real quick here. Change of base formula. If you have a base in log base 3, for example, but we don't have a log base 3 button, we only have that log base 10 button, common log 10, you're going to change the base using this change of base formula. So say I have log base b of a. That's the same thing as log of a divided by log of b. All right, so here we go. Here's an example already done for you. Log base 4 of 72 equals log 72 over log 4. So what you do is you just type that in your calculator. Log 72 divided by log 4, and it's 3.08. Just going to round these. 3.08. Okay? Log 5 of 163, crazy numbers. I can't figure that out in my head because 163 is not a power of 5, so it's going to be some decimal, right? So all you do is log 163 over log 5. This is the change of base formula that allows you to find crazy logs that are not nice numbers. Log 163 divided by log 5. Right in your calculator, 3.16. We're going to have to put approximate here, a little squiggly, 3.16. And the next one, log 7 divided by log 50. So it's log of the amount divided by log of the base. So log 7 divided by log 50. And that comes out to be 0.497. Approximately 0.497. Okay? And solving for unknown exponents. So here we go. We're just going to be using the log of base. The first one's done for us. We just have 2 to do. 5 to the x equals 1200. I don't know. 5 to the something is 1200. I don't know what that is, right? Big numbers. What do I do? Well, change it to a log. So I can go log base 5 of 1200 equals x. See? Now I can use my logarithms, right? Log base 5 of 1200 equals x. So now x is going to equal the log of 1200. Just use the change of base formula. The log of 1200 over the log of 5. This is the change of base formula. And I just type that in. Log of 1200 divided by the log of 5. And that's going to be about 4.4. Approximately 4.4. Oh, three decimal places. 4.41. 4.41. All right, here, again, 8 to the blank equals 17,000. No idea, right? So I'm going to go log base 8. What power of 8? See? Remember that what power? Think of it like that if you're still getting confused. What power of 8 is 17,000 equals x? See? That's going to be, whatever this comes out to be, that's going to be my exponent. All right, so I'm going to go log 17,000 divided by log 8. And that's just going to be log 17,000 divided by log, oops, I hit ln. log 8. And it's 4.684. 4.684. All right, so there is, so basically what that means is 8 to the 4.684 power is going to give me 17,000. 8 to the 4.6 is going to give me about 17,000. So that's kind of what we're doing. We're finding missing exponents. That's what logarithms are. Practice these more in class tomorrow. See you then.